Everybody, I will assume that you can all hear me. If not, please write on the chat that you're experiencing problems. And I think we are ready to start. Let's see. Okay. All right. Okay. Well, hello everybody again, and Happy New Year. Welcome to the first session of the Full Academy for the DLT4ALL MOOC, the Erasmus Plus project that we have been running now for a couple of years. We are starting this week with an introduction to blockchain, and thereafter, for the following 8 weeks, we will be covering the rest of the modules. The material for all the modules that I will briefly show them to you in a few minutes has been designed and developed following a series of workshops where we would be obtaining, discussing the syllabi with you and obtaining your feedback. So it has been designed based on the feedback that we have been receiving from these different types of workshops. The Full Academy, according to the project, was supposed to be done face-to-face. But unfortunately, due to the pandemic, we had to move everything online. It was going to take place face-to-face in the different countries participating in the DLT4ALL project. That is besides Cyprus, Greece, Belgium, Italy, and Spain. And so what we have decided to do instead for the rest of the 2 months that we have, we will be covering one module every month. And the whole module we span from 4 to 5 days, a few hours every day. And we have embedded also within every week other activities such as invited speakers to discuss and experts to discuss. For example, we're having for module 0 an expert tomorrow to discuss the use cases that they have been implementing for their case. Someone is typing. Valentina, no, you're muted. I hear some typing on the background. I'm not sure who is. So please mute. And we're ready to start with module 0. So initially, when we actually started the project, we were not intending to have an introductory course, this module 0. But then soon we realized that we would need to cover in every different module the basic of blockchain technologies, just in case the audience for the corresponding module were not aware of it. So we decided to introduce another module to cover the basics of blockchains. So it has been divided into logical parts. The first part, we will be introducing the DLT4ALL course, which it's approximately with the different activities, it's going to be about 130 hours long that we will be covering for the rest of the 2 plus something months. And we will be identifying the different target audiences and parts of the curriculum that need to be addressed for each one of them. So in the second part, we will be giving an introduction to the blockchains, starting from a historical perspective, and moving into the technical requirements for blockchain, and give also a short taxonomy of blockchains, define smart contracts, what are decentralized applications, and conclude with some use cases. Tomorrow, we will be discussing more use cases. And on Friday, we have set up a couple of hours aside for office hours in case you have questions. So I think I can skip this slide. So what we're going to do, we're going to recall the DLT4ALL structure, define the audiences we set, understand the available certification process. Those who finish all the modules, they can, we will be issuing a certificate for them. I will mention the requirements that are needed for that. And besides that, then we will go into the technical components of blockchain. What are cryptocurrencies, smart contracts, decentralized applications, and the use cases. This is the syllabus that we see here, what we'll be covering, in other words, for the next 3 hours today. So a few words on the project as well and how it all started. For the past years, we see that DLTs are actually promising to change several industries with major economic and social implications. When we were looking into this, we realized that there was a lack of knowledge by many in understanding what are blockchains, how they could adopt blockchain technologies, where to use them, in terms of both growth and innovation. So the aims of the project were and are to address the lack of entrepreneurs, students, angel investors, and incubator managers in understanding and exploiting and how to exploit blockchains and distributed ledgers. So we have co-created and deployed this curriculum that we will be presenting. There will be we were intending to have a mixture of classroom, of course, face-to-face interaction. We are having workshops scheduled almost every month. That usually you receive emails when we have them scheduled to receive more feedback from you to discuss other use cases. And we have created also this MOOC style online learning. We will be having this online long, I would say, sessions for the following weeks. But at the same time, all the material is uploaded online for everybody to access to it anytime they wish, and go over it and to understand what is the whole material about. At the same time, we have short assignments within each module. And at the end of the whole MOOC, that is for those that are covering all the different modules, there will be a final exam that will be given approximately a month after the modules finish. The initial target audience for DLT4ALL, as we have mentioned, were university students, researchers, entrepreneurs for startups, high-tech SMEs, early investors, and incubator managers. Of course, anybody who is interested in blockchain material, in blockchains and DLTs, this MOOC, I believe, is very suitable for them. We are addressing both technical and non-technical people. And this is why, at the same time, for most of the modules, we have allocated a day in the week that the specific modules will be offered to not to go so deep into technology, but we will be addressing more business-like people that are not into the so much in the technical aspects. So as I have said, we have designed it for all different types of groups. So just lay back for a second and think in which group also you would classify yourself. The thematic priorities that we are covering are peer-to-peer database design, encryption techniques, consensus mechanisms, digital signatures, property rights, smart contracts, distributed autonomous organizations, blockchain-based decentralized applications, and this module 0, the current module, that we are covering today, which, as I said, gives an overview of blockchain technologies to serve as the foundation for the rest of the modules. There will be assessment for those, of course, interested in doing the assessment, in receiving a certificate. For every module, as I already mentioned, there are short assignments, some sort of short assignments that will be graded. You will have a specified period of time to finish it, a few days most probably. And when having passed 80% of the shorter assignment within those modules, you can go and you can have access to the final exam. The short assignment will count 30% of your grade, and the final exam will count for 70% of the grade. Those who finish, of course, successfully, we will be issuing a certificate of accomplishment for them, and we will be issuing it on the blockchain. As most of you know, the University of Nicosia was the first university to issue certificates on the blockchain. We have a spin-off out of that. So we're using our spin-off to issue the certificates on the blockchain. So this brings us to the end of the first topic, and I will quickly move to the second one. Let me close the other one. You're looking now actually at the schedule that we have for the rest of the close these things. Oh, okay, why can't I do this? Let's see. Module 2. All right, here. And I need to do this. All right, so I hope you can see my screen. So in this section, we will be just having an intro to blockchains, give a short historical overview, look into the various technological components of a blockchain-based system, and at the end, we have lots of references for further reading for you. Blockchain. What is actually blockchain and when was it introduced? It was introduced back in 2008, just a decade over, as the technology underlying Bitcoin. Bitcoin, as you know, was the first cryptocurrency. It was invented initially to support this cryptocurrency, but soon afterwards, industries realized the potential of the technology as such and started to exploring with it for different types of applications, ranging from financial services to supply chains, to the energy sector, to hotels. So they soon realized that this type of technology had could influence a lot of different industries and improve the current practices that we were using, or that we are currently using also. And you're going to realize why when we start to explain what this is actually. Bitcoin, the cryptocurrency Bitcoin now, is a private, decentralized, digital cryptocurrency. Decentralized in the sense that there is no issuing party, there is not a central authority for it. No government is behind it. And units are issued using algorithms. It's digital in the sense, of course, that it is fully electronic with no underlying peg to assets. And it's a cryptocurrency in the sense that anti-counterfeiting, it is anti-counterfeiting through cryptography. In other words, it is very hard to hack it. And we see it actually as two innovations. First, a store of value for people who wanted an alternative to the existing financial system. And the second way is to look at it as a new way to develop open, decentralized networks. Looking at the historical overview, initially, as we've mentioned, it was introduced back in 2008 by someone by the name Satoshi Nakamoto. Nobody actually knows who this person is. When he published a paper to introduce Bitcoin. The following year, the first Bitcoins were mined, and the first big Bitcoin transaction takes place when Nakamoto sent to Hal Finney 10 Bitcoins. 2010, another historical event, and actually with this past week's of fluctuation of Bitcoin and prices of Bitcoin, I believe my 80 million euro there is wrong. A Bitcoin user buys 2 pizzas for 10,000 Bitcoins. So imagine, last week, Bitcoin reached more than 34,000 euro. So 10,000 times 34,000, imagine how much euro. You can just do briefly the calculation to see those 2 pizzas, how much they cost. 1 Bitcoin equals to $1. And other cryptocurrencies started to appear as well, such as Litecoin. 2013, we see the first fork, Bitcoin fork. In other words, the various Bitcoin holders, they do not agree on the transaction rules that exist at the time, and the whole network is split into 2, and we end up with 2 networks running in parallel. 2014, Mt. Gox goes bankruptcy. Mt. Gox was an exchange based in Japan. It went bankruptcy and left its investors empty-handed, basically. The following year, 2015, more cryptocurrencies emerged, including Ethereum. And 2016, cryptocurrencies continued to rise and become more and more popular. 2017, another fork takes place. 18, EU governments realize now the potential and the power of Bitcoin, and they start joining forces to develop legal frameworks to regulate it. 19 cryptocurrencies are more and more become more and more accessible to users, and last year 2020, besides the pandemic, most people will remember 2020. Mute your mics.
Quando vão ter muitas horas assim.
Sim, normal, pero quando estou a falar do frio parado em qualquer sítio.
Hello.
Uma infusão a relógio.
Please mute your mics.
Vou deixar aqui a postilhas aqui.
Valentino, can you mute?
Coloca ali em cima do de ancho. A caixa da silla.
Okay.
Em cima do de...
All right. Sorry about that, everybody. All right. I was at the last point here saying that most of us, I mean, people will remember 2020 as the year of the pandemic. But for the blockchain enthusiasts, it will be remembered also as the year of decentralized finance. In January of 2020, the amount of money put into DeFi apps was about 700 million. By the end of the year, in December, it reached about 13 billion. So we see this huge explosion in decentralized financial applications. So moving into some more Bitcoin basics. Is Bitcoin a currency? This is the question that many people are asking. It is actually a form of digital currency and the first cryptocurrency, created, as we said, electronically on a computer and produced all over the world using advanced computer software that solve mathematical problems. They are not paper money like dollars or euro, what we are used to, or yen, in the sense that they are not issued by central banks or other monetary authorities. They are private. That is, they are not used by a state authority, and it enables a pan-global means of exchange. In other words, wherever you're in the world, you can transfer money via the computer, via your smart phone, immediately with relatively low transaction fees, much less than what the bank would require. Just flowing from one wallet, digital wallet, to another. No fake coins, in the sense that they're based on cryptography that enables the anti-counterfeiting. It is a global means of exchange because, okay, Bitcoin, first of all, it's a fixed asset. There are only, well, there will be only 21 million coins produced. Central banks or monetary authorities do not actually control this number of Bitcoins that are flowing. It is how much they are actually produced by the system itself. Anyone with a computer and an internet connection can set up a Bitcoin address to receive or transfer Bitcoins in seconds. Many say that they are anonymous. This is sort of kind of false. They are pseudo-anonymous, in the sense that there are ways and there are companies working on that to try to identify who has, to trace basically the Bitcoins and their owners. At the University of Nicosia, part of our research, Elias, afterwards, my co-instructor, that will take over for the next section, sorry, can discuss a bit also on that, how we have done some research in trying to trace Bitcoins. It also allows users to maintain multiple addresses, and setting up an address requires no personal information. And it is the DLT technology that makes Bitcoin, as we're going to see how it works, it makes it transparent. It is divisible, so the growth potential of the exchange medium is unlimited. And in the Commodity Futures Trading Commission in the United States back in 2015 designated Bitcoin as a commodity. I think we have mentioned that. If there are any questions, meanwhile, please feel free to type them on the chat or unmute and speak out. Feel free to do that, to ask questions. We can look, okay, enough about Bitcoin. I would like now to go a little bit more into blockchain. We said that Bitcoin is the cryptocurrency. At the same time, the blockchain that supports Bitcoin is called the Bitcoin blockchain. But blockchain is actually the technology, the underlying technology that supports the cryptocurrencies. Blockchains can be defined also as distributed ledgers of any type of transactions, whether those transactions concern, for example, medical data, student data, financial data. So transaction is actually the exchange of data that, as we said, could represent any type of data. They are shared because we need more than two parties to be involved. If we have only one party, then it doesn't make sense to have a blockchain. We're just talking about the centralized system. Timestamped transactions are stored in chronological order. So when we have a transaction stored in the blockchain, there is the time when that transaction has been there. It's append only, or append only, in the sense that we can only add new transactions on the blockchains. And once we add them, we cannot modify them. They're cryptographically secured through advanced cryptography. And also, we can have smart contracts. In other words, they can program so that certain conditions are met. Looking at the diagram here, I'm not sure, probably you can see my mouse as well, moving on the screen. All right. When we're talking about a centralized ledger, so basically all the data, they're stored at one place. So in this example, we have various banks and there is only one centralized ledger. When we're talking about a distributed ledger, all the various peers, they have their own copy of the data of this ledger. So let's say that for a modification to be done, in this case for bank one in the to other transaction, let's say here in this centralized ledger, the rest of the peers have to agree and add it also themselves. So a ledger, when we look at ledgers, what are they actually? They keep track of all our transactions, and we use them in any sort of business. They reflect a permanent summary of all the amounts entered. We keep a log of them, some sort of a journal, a listing of all the transactions taking place. Imagine of a ledger with all your financial transactions in your checking account, for example. So examples, as we said, everywhere. We find ledgers everywhere, from citizenship records to bank accounts to credit cards to accounting ledgers, land registries, medical records. So wherever, hotel bookings, whatever we do, we use, in any type of business, we use ledgers. So in a ledger, we cannot allow anybody to enter a transaction. That is, we do not allow, of course, anybody to modify or insert data in a patient's medical record, for a patient data, or we do not allow anybody to modify our bank data and the transactions that we have there. So in order to do that, we require a trusted party to be in charge of all important ledgers. And to identify a trusted party, it's hard to do, if not impossible. What we need to remember about blockchains is that it allows unknown parties that they may not know each other, and of course, if they don't know each other, they don't trust each other, to transact with each other, even though they don't know each other and they don't trust them. The transactions cannot be censored. They cannot be modified by the various record keepers, and they cannot be lost. So we can say that blockchains eliminate the need of the central ledger. It consists of blocks that hold badges of valid transactions that are linked to each other by one-way hashes, as we're going to see in the following examples. Can be open, verifying anonymous actors in the network, or they can be closed, as Elias will be talking to us later about the different types of blockchains that we have, and require actors in the network to be identified. The main idea behind it is the fact that there is no central record of transactions. Many copies of these ledgers, they are distributed around the world, and each owner of each copy records every transaction. And every transaction to be recorded, it has to be approved by at least 50% of the various peers. Let's look at this example here that we have. Now, in this example, we see Helen, a mother, that wants to send €1,000 to her daughter, Mary, who is studying abroad, and Mary is supposed to use part of that money to pay the rent, 400 euro to be exact, as we see here in this example. Now, the first thing that we need to do is the bookkeepers. Okay, where's my mouse? Here it is. The bookkeepers first need to check Helen to see if she actually has this 1,000 euro. So we see that Helen has actually 10,000 euro in her account. Mary has 100 euro. This is the current situation in her account before any money is being sent. And the landlord has 20,000 euro. So once the bookkeepers confirm that it is okay, Helen has enough money, she can then send the 1,000 euro to her daughter. So she sends the 1,000 euro to her daughter. She's left then with 9,000. Mary in her account now has 1,100 euro since she already had 100. And the landlord at this point in time has not received any money yet. Now, Mary then sends the landlord. Okay, of course, again, the bookkeepers will need to check if Mary has enough money in her account to send the 400 euro. So she has enough money. Mary will send the 400 and she will be left with 700 euro. Helen still has the 9,000 after she sent the 1,000, and the landlord has 20,400. There is no way that a fake transaction can make it in, because then this this situation here then, because everybody's keeping a copy of the situation, the current situation, then they will not be able to modify it. If a modification takes place, then everybody has to modify it. And I thought that we had a different slide here. Okay. Okay, I understand that in a while all clear. There is a comment here. Let's see. I understand that in a while all clearing houses may disappear. Well, it depends on the adoption rate. The while we cannot really define it right now. So it will depend on the adoption of all these different decentralized applications. It will depend, and to be able to adopt all these different technologies, there are other reasons. We need, there are reasons such as regulation. Governments, regulators will not let it just go like that. And by the time regulators, in my opinion, put the legal frameworks in place, and people start, industries, banks start using these different applications, eventually, in my opinion, yes, clearinghouses the clearinghouses as we know them today may disappear. The thing to remember, clearinghouses act as intermediaries. Intermediaries with, when we're using decentralized applications, are not necessary. They disappear. I hope I was clear. Technological components, I'll continue with the technological components of the blockchain systems. Okay, some buzzwords to remember. What happens when there is a fork? okay, usually when there is a fork, the network is being split in two, and you can see there's another cryptocurrency being formed with the partial network, and then of course others may join into that. Okay. This is what happened with the Bitcoin and the Bitcoin Cash. All right, buzzwords. What does it mean someone will benefit from a newly created cryptocurrency? Well, a newly created when someone creates usually a cryptocurrency, they try to base it on some sort of an application. And they will benefit from the types of applications that they will be using. Creating a new cryptocurrency usually goes back to the fact that they are actually creating a blockchain, the blockchain that will support the new cryptocurrency. So on that depending then on what types of applications that blockchain will be supporting, then the cryptocurrency value will rise or fall. The rise or fall of the value of cryptocurrencies depends on many factors that none of us actually can very clearly not understand. It's based on very factors that we cannot I would say, understand right now. If we knew how the cryptocurrency's value falls or rises, then I think we would all be millionaires. So, okay, then let me see if there are any other questions. Okay. In order to decide on a new cryptocurrency, please remember that you have to have an application in mind that you want to support. Once you have that application and people are starting to use it and adopt it, then this is how you benefit from your cryptocurrency. Now, buzzwords we need to know. Bitcoin with a small b describes the unit of account. In other words, the currency. Bitcoin with a capital B describes the blockchain, the Bitcoin blockchain. Address, another important thing we need to remember, is a location that Bitcoins have been sent and reside at, stay at. Alternatively, it can be thought of as an account of sorts that has a balance of Bitcoins. So, for example, someone in his address may have 3 Bitcoins. If that person has 3 Bitcoins, what is the value today? I saw it was something like $30,000. So if that person has 3 Bitcoins with today's value, it will be around $90,000. Blockchain, so $90,000 reside in that specific address. Blockchain is the complete transaction ledger of the Bitcoin network or any other cryptocurrency that we are referring to. And it's showing how Bitcoins, they can be transferred from one address to another over time. The blockchain is a public record of all Bitcoin transactions in chronological order. We can actually go to the Bitcoin Explorer there and see all transactions that took place since the beginning of, since the genesis, since the beginning of Bitcoin. So you can find on the internet, in other words, all different transactions that have taken place. Transaction, as we said, is the exchange of data that could represent any type of data. In with Bitcoins, we mean the movement of Bitcoins from one address to another. In traditional terms, it can be thought as a payment movement, paying someone with Bitcoins. And yes, there are organizations that do accept payments with Bitcoins, with Ethereum. Actually, the University again of Nicosia was the first university in the world to accept Bitcoins back in 2013, actually, for the tuition fees of our students. Now, Bitcoin versus blockchain. You need to remember that Bitcoin is not the same as blockchain. Bitcoin, cryptocurrency, and also one specific blockchain called Bitcoin. So, blockchains may be used, as we said, to establish trust between different parties that do not trust each other, removes intermediaries, and we're talking about a decentralized system. Various peers keeping the whole, where all of them are keeping copies of the same ledger. Some more definitions that will come handy to understand, some more basics on how blockchains work. Hashing. Hashing refers to the fact that to algorithms, when we apply algorithms to generate a value of some sort of a string text or using some mathematical function. Every time we apply a hash function to some data, we get the same hash value. What's important to remember here is the fact that hashes are one way. In other words, once I give it the input data, and I do the hash, I cannot, from the output, go back to the initial input. Bitcoin uses the SH256 hash. It could be either in 64 hexadecimal characters, or actually they're represented as 64 hexadecimal characters. Look at it, as I don't want to get too technical, look at it as a string of various characters. I will show you here an example. If you go online, you will find several types of hashes, several hash algorithms that work online. So if I type here, for example, I already had it typed earlier. So if I type the phrase, hello world, and I use the same, they're all different hash algorithms. We said that Bitcoin uses the 256, the SHA-256, and this is what I get. If I make the slightest change here, so let's say hello world, my output changes totally. All right, now I need to go back to the presentation here. Now, a nonce is a number that we use once. It is added to a hashed block, an encrypted block, to meet any difficulties when someone is trying to rehash it. And I'm sorry. This is actually what the miners, they are looking to solve when they're trying to mine. They are looking for this number that we insert in the hashed block when it comes to Bitcoin. Cryptography is the practice basically of developing various protocols that do not allow others to see your actual data. It combines from mathematics to computer science to physics to engineering. There are various cryptography algorithms that are being used. They can also be used when we're sending emails, when we're sending text, to encrypt what we are sending, so that in the case that someone intersects the message, not to understand what we have sent. So it involves encryption. In other words, the scrambling, let's say, of the message from its original form to some unreadable form, and the decryption, the person that receives the encrypted message to use some sort of keys to decrypt it. And cipher, we refer to the algorithm that performs the encryption or the decryption. Actually, encryption techniques, they are not new. They go back as you know, to the ancient Egyptians. One of the most famous, I would say, encryption ciphers that has been around since ancient times is what we refer to as Caesar's cipher, where in order for Julius Caesar to communicate securely with his generals, they would shift the letters by a couple of places. So, for example, an A would become C, and B would become D, and so on. Now, as we said, in a blockchain, we have lots of transactions. These transactions are being bundled. We put them together in blocks, and these blocks, they are linked with each other with a one-way hash. In other words, as we see here, oops, okay, here's my mouse. If we have in block 0 the data high, and this was, you know, we see also the timestamp when this transaction took place. In block 1, then, that took place afterwards, with data singing in the rain, we link the two blocks with the hash. So block 1 points with the hash to block 0, and once a block is then of course the following block is again, block 2 is linked with a hash to block 1, and so on. And this is how the chain is actually being formed. So a block may actually contain multiple transactions. Once a transaction is added to the chain, as we have already mentioned, it cannot be modified. And they are validated by the various network participants and recorded in chronological order. And these transactions, they are protected by these one-way cryptographic functions to keep them secure. So, referring to this part here, to the chain as I have it, my ledger, I will move. So please keep in mind this ledger that we have here, and I will move to this one. So assuming now we have a network of 4 nodes, each one of these nodes keeps the whole blockchain, the whole ledger. They do have a copy of each one of these, has a whole copy of it. So we're looking here at a decentralized ledger, which enables the recording, the storing, and the sharing of cryptographic data across the multiple ledgers. Each ledger has the same information. It has the same information because the various participants, the nodes, agreed that that transaction would be added to the chain. If they had not agreed, then the transaction would not take place. How are transactions validated by network participants? It's coming up. Give me a couple of more minutes for that. So no intermediaries are involved. And of course, everything takes place algorithmically, and human error is eliminated. Data are also stored cryptographically in the blocks. And now to the validation point, we are using consensus algorithms to verify the transactions and enable the addition to a specific transaction to the ledgers, to the ledger. So consensus algorithms are responsible for validating the transactions. Now, when it comes to, of course, there are various types of consensus algorithms being used by the various blockchains. The Bitcoin blockchain uses, as we're going to see, proof of work. So consensus algorithms, they are the mechanisms through which a blockchain network will reach consensus. In other words, to agree that this transaction is okay, we can add it to the chain. Public blockchains are built as distributed systems, since they do not rely on a central authority, and the distributed nodes need to agree on the validity of the transactions. The consensus algorithms, they are, of course, a very crucial element to every blockchain, and they are responsible for maintaining the security, the integrity of all these systems. It provides the means of distributed nodes to reach consensus, on which depending on which version of the blockchain we are using. And agreeing upon the current blockchain is essential for any digital economic system to work properly. So, as we said, proof of work now is being used to confirm the transactions and produce the new blocks to the chain. With the proof of work, the various miners compete against each other to complete transactions on the network and get rewarded. This is why they do it. Every time a block is created, the person that validated the miner, the node that validated first, then is being rewarded. If we're talking about Bitcoin, a certain amount of Bitcoins. Now we are at the at 6.25, if I remember correctly, Bitcoins per block. The main working principles are rather complicated, as they're using different mathematical puzzles, and we will not be going too much into those specific puzzles today, as then we're going more technical. So, what you need to remember is that the consensus algorithms, they are an essential part of the mining process. This is basically what we use to validate the transaction. It involves numerous hashing attempts, and probably you have heard that there is a need for lots of energy when we are using when we're doing mining. It's because of all the computational power that is being required to do all this hashing. Another consensus algorithm is proof of stake. Of course, as I said, there are many. We're just going to touch on a couple of these now. We have a specific module that covers consensus algorithms. Now, proof of stake was developed in 2011 as an alternative to the proof of work. It replaces the proof of work mining with a mechanism where blocks, they are actually validated according to the stake of the participants. That is, the validator of each block is determined by the investment of the cryptocurrency itself and not by the amount of the computational power allocated. Of course, there are some differences with the two of them. And as I said, consensus algorithms and more of them will be studied in much more detail in the module on consensus algorithms. And this brings us to the end of this topic. Here we have listed some references for you for digging further into this material. I will pass now the floor to Elias, Dr. Elias Yosif, my colleague and my co-instructor for this module. We'll continue with the next topic that we have. So, Ilya, the floor is yours.
Thank you, Sula. Let's do a quick checklist. Can you see me, hear me well?
Yes, we can, and I'm gonna mute myself.
Okay, thank you. Can you see the screen I'm sharing? Specifically the slides I'm sharing?
No, Ilya, we cannot see them. Did
So
Valentina, did you pass the token to Ilias?
Yes.
Are you using screens, Ilya?
sorry, Sula?
Are you using 2 screens?
Okay. Something has changed in WebEx.
Yes,
So
can you see the share button?
it's not activated.
Do you want me to share it and then I can just go to the next?
But I was preparing also to.
Yes, now?
Yeah.
Okay, well,
Can you see it now?
I don't know why the
I suggest a 5-minute break because, okay, 3 hours for all of us, it's too long to be sitting around. So I suggest a 5-minute break then. And
okay.
until
Let's see.
so it's I show 7:14 now on my laptop. So let's all of us grab a coffee. And unfortunately, we're not face to face to offer you the coffee. So we'll be back at 7:20.
Okay.
Valentina, stop the recording.
Welcome back, everyone, and thank you, Sula, for passing the floor, the virtual floor, to be precise, during the working remotely. So I'm seeing that the share functionality has been enabled.
Yes.
Can you see my slides?
I can see it.
Yes. So I guess also let me let you know that I have a second system connected to this webinar, just to have a real look and feel how my presentation delivered by machine number 1 is delivered to you, and that's why I have machine number 2. So when I'm looking this way, is just to make sure that you can see my share content. So once again, welcome to this introductory webinar, being part of the DLT4ALL project. I think that Professor Ka has provided an excellent background regarding the blockchain, the basic motivation behind blockchain, and the mechanics of blockchain, because after all, blockchain is digital technology. So yes, adoption is important. The regulatory framework is important. The business perspective is important as every other type of technology, either digital or something different. But at the end of the day, this is a digital thing, and digital technologies, the technological perspective is the cornerstone. But and around this realization, the material of DLT4ALL has been developed without, of course, ignoring the business and the regulatory dimensions. Okay, this is quite, I think, quite familiar to you, but I would like always to keep this in mind. Also, after the break, I'm sure that you have grabbed a coffee, so I did the same. This is my coffee. So, and I invite all to participate in a live discussion. So feel free to interrupt me. I'm here to take questions at any time. That's why we'll periodically looking at the chat. And this is a two-way interaction. So the first way is to interrupt me and ask a question, but at the same time, I would say, because this is a decentralized motivated webinar, we have a decentralized setup, meaning that privileges are uniformly assigned. I have also the privilege of asking questions. So in addition to your questions, I think useful and interesting to ask questions and see your views. There are no correct and wrong answers, so feel free. And before doing this, let me make the bridge this part of the module with what was presented previously by Sula about the inner character of blockchain. So, as you have seen, the heart of a blockchain is the ledger. So my question, my very first question to you is whether you have an idea where a ledger can be stored, how a ledger or a blockchain looks like. So, any ideas? Please keep in mind that blockchain is a digital type of technology. So we are talking about digital things. Any ideas? Yes, it's excellent. So a database. I see an interesting answer. Huge servers. I think the answer, I think you are covering all the spectrum, because there are, as this slide suggests, we have different types of blockchains, and each type of blockchain dictates the exact format of storing and accessing this blockchain. So I think the generic answer is yes. We need files. we may also need databases, and let's see if this is huge or something differently. This is I'm going to show you my personal copy of the Bitcoin blockchain. So this item definitely is very familiar to you. This is an external hard drive where I store and synchronized one of my personal copies of the Bitcoin blockchain. I tend to have a couple of them. Any observations about the fact that the most famous and widely used Bitcoin blockchain, which is of course the Bitcoin one, can be stored into a low-end device? For sure, this is not the cold wallets. Something different. Wallets has to do with the management of the address you are holding. This is, I'm talking about the entire Bitcoin blockchain. So, any this is not a cold wallet, no. It's the medium where the entire blockchain is stored. Any observations, any comments about this? The second one is for backup purposes. It's for me. As in the previous question, there is no. I'm not sure about the question. What's the name? What's the name of the blockchain that is stored into this drive or this specific drive? It's a typical external hard disk that can be connected to any machine. So the name does not play a role. You can use any external drive being available in the market. So what I'm trying to say, yes, and it contains the entire Bitcoin blockchain. What I'm trying to say here is that at the end of the day, the blockchains are not something very different compared to the files that we have in our machines. The fact that I am in a position to download the blockchain, the Bitcoin blockchain, and put it into that hard drive means that this particular Bitcoin is public, and that's why I have this this opportunity to download it. Let me see other questions. Regarding the role as a validation or not node, this has to do with the setup while you are running your machine. But the high-level answer is that yes, having such a copy, you can be one of the nodes that validate the transactions. But again, the main message here is that the blockchain itself is a set of files nothing very different to what we are using for other digital purposes. And the public blockchains enable the downloading and the possession of such data. So this question is about the validation process. It will be detailed in the subsequent courses. Let me just mention the quick answer here is by applying a set by following the proof of work by following the rules put by the consensus algorithm we used, and which for the case of Bitcoin blockchain is the proof of work. So by moving into that context, which includes the application of numerous computation intensive operations, you can validate a transaction and you can validate blocks. This is the approach. So this gives me the chance, referring to the latest question about keeping a copy. This gives me the chance to mention that one of the main features of public blockchains is the fact that a copy, as Sula mentioned, is kept in every node. So assume that my copy is being lost or destroyed. I can easily connect to the network and download another copy. This is one of the advantages of the public bitcoins. So let me do a quick switch and move towards the other end of the blockchain types. Now I'm going to share with you the terminal screen that runs on my laptop, from where I'm giving this talk right now. In my local file system, I have installed a private version of Ethereum. So can you see a black screen, a terminal? It seems that you can. Yes. So let me list the basic directory structure. I have highlighted the so-called genesis.json file. If I let me open this Genesis file. This is just to let you to illustrate that as far as I have access and full control on this Genesis file, this, among other things, means that this is a private network, in contrast to the public network. So here I can, for example, modify some parameters that determine the characteristics of this private network, like the difficulty. Also, I can assign some funds in an address, etc. Let me save this and list again the files. So this is a small private Ethereum-based network stored in my machine. Let me enter the geth directory. So here you can see a folder called chain data. So let me enter this chain data folder, and okay, let's clear the screen. Here you can see actually the blockchain itself. This is a small blockchain because it is private, and it was built by me for demonstration purposes. The main message here is that the blockchain itself consists of two basic and simple files. The first one has the extension .lb, which is okay. Before mentioning what LDB stands for, let me ask the following. In many cases, we hear that blockchains are different compared to traditional databases. Did you hear this distinction? Also, many times I hear that blockchain can change how data are or were traditionally saved and managed in traditional relational databases. Correct? So one may that's true. One may say, okay, yes. Let me now explain what LDB stands for. LDB stands for level DB, level database. So this file here means that a database is being used by the Ethereum private blockchain that that runs on my machine. The other file, log file, is a plain file which stores information, the needed information, in order to put the set of transactions, the set of blocks into chronological order. The ordering, in other words, the ordering of the transactions is made possible by encoding some time-related information into an ordinary file. So again, I'm demonstrating both the external hard drive as well as this snapshot of my local file system in order to quickly check the distinction between public blockchains like Bitcoin, which can be installed in an external hard drive, the private versions of public blockchains like Ethereum. The most known version of Ethereum is public. However, the exact same code can be used in order to install a private version. And under this distinction, the common theme of every type of blockchains is that the blockchain itself as a data structure, for the majority of cases, I would say for all cases, utilizes databases in combination with plain files both of them are being stored into a file system in a computer. Of course, this computer for industrial strength applications is in many cases is a server. So I'm seeing a question. Okay. Okay, the question is whether Ethereum blockchain is public. Yes, it's public, but you can take the system as a source code and develop your very own network, which can be either public or private. The one that is being showed in the terminal is a private one, and everything in between. And this is the main topic for discussion for this part. Network of nodes, of communicating machines, where the machines validate transactions. So I'm closing right now the terminal. So the log file includes some information which is useful for putting blocks and transactions into a chronological order. So the LDB file has to do with some details about the transactions. It's a very deep technical topic, and for which we can talk and discuss for hours. What I wanted to show here is that those things, the blockchain itself, the ledger itself, is from a physical, let's say, perspective, is a database plus some typically plain files, nothing more. Yes, LDB stands for level database, which was developed by Google. Other blockchain systems like Hyperledger, for example, may use other databases. For example, Hyperledger supports two different databases. During the installation, you can choose which one to use. Those two are LevelDB and CouchDB. But the main message is that despite, let's say, the myth that blockchain replace databases, blockchains use databases as a data structure. What is being replaced is, and this is the question to you, is not the data structure per se that is being substituted in the era of blockchain. What is being substituted by blockchain is the let's say, yes, I think Stelios' approach is close to what I was about to say. Is server. Server means that there is yes, it's about the decentralization and the governance of the access to the data and to the mechanisms that justify the validity of the data, meaning to the mechanisms that validate the transactions and the blocks and the associated smart contracts if we are dealing with blockchains that support smart contracts. So it's not the data structure per se that is the element of interest, is the governance and the access to it. And this dimension is the important parameter for characterizing a blockchain as a public or private, as a permissionless or permissioned. So in essence, assume that the data structure, meaning plain file or database. Okay, let me go back to this example here. Okay, so let's revisit this example here and see that and focus on the two main files, the data files and the log file. These two files constitute the blockchain itself. And previously, I have said that this is a private blockchain, correct? So I am the at least for now, the only owner of this system, of this network. I am the only person on on Earth that can access this data, the data included in the LDB and in the log file, correct? Because as I said, this is a private blockchain. Do you agree with that? Okay. So what happens if for any reason I can give you access? The user stuff is just a group name in my computer. Plays no role here. So you can ignore the this stuff label. So as I was saying, this is a private Ethereum-based network that runs on my machine, which is implemented mainly through these two files. And I was discussing the idea of what if I give you access to those files, then what happens? Any ideas? Yes, starts. So all questions have something interesting to discuss. So one question says, becomes public? Yes, starts to become public. The other question is, to anyone? This question suggests that we can start creating groups of users. Each group may have different access rights. So yes, answering to Dano, yes, if I have, and this is the power of public blockchains like Bitcoin, if I have a strong consensus mechanism I do not care about someone stealing the data. Is like the Bitcoin case sharing the data. So parameters like what type of access, read-only access, read and write access, access to everything, access under conditions is what makes a blockchain being public or private and everything in between. So it is important to understand that the character public or blockchain or private is not binary. It's not yes or no. It's a continuous spectrum which depends on the types of the privileges of access you are granting to the nodes. Also, this is closely correlated with the permissioned or permissionless. So these two basic dimensions which live in a continuous space is not a binary discrete space characterize your blockchain. So returning back to my example, I can easily add access rights to this particular small private network and start this way making this network public. So this is the basic idea. Any questions up to this point? So in other words, it's everything. Okay, this is not the full picture, but it's the basic idea. Because as Sula mentioned, in DLT4ALL, we have a list of topic-specific modules where the details will be explained. But right now, I'm giving you the basic idea. The character of the blockchains has to do with the access to the blockchain. And as it was described, the blockchain is a set of files that live in your computer or in others' computer. As far as you have certain access rights to these files, these access rights determine the type of the blockchain. Yeah, responding to the latest question. Yes, it's a matter of at the end of the day, it's a matter of access rights. So, if, for example, only a subset of nodes can download and store into an external drive the Bitcoin blockchain, of course, this changes the character of the blockchain, making it as semi-public or something different. Again, this is not a binary characterization, public or private. There is a spectrum which is a continuum. Yes, also the consensus play a role, a central role here. So let me and thanks for mentioning consensus. Let me ask, do you see any fundamental difference between the consensus algorithms that should be used for the public case and the private case? Do you believe that a single type of consensus algorithm can work for all types of blockchains? No. And I would say yes. I would say no, I agree with you, but why? why we need different types of consensus algorithms. Yes, speed, but I think yes, it's related. It has to do with speed and the throughput, number of transactions are relevant dimensions. However, the most major characteristic that determines the type of the mechanics of the consensus algorithm has to do with security. Yes, that's. I think that is answered by the last post. Public blockchain needs stronger consensus algorithm than private, and this is because of mainly security. Because by definition, in a public network, you have you give the opportunity to anyone to participate in the network. So you need to have in place a good security mechanisms implemented within the consensus rule to make sure that everybody follows the rule. If, for example, I'm going to use my small private network, this one, shown here, and invite Sula, Professor Sula Luga, to participate as a second node, because I fully trust Sula, because we are co-instructors with Sula in DLT4ALL, because we are teaching and doing research in the same university. I have full trust regarding Sula's participation. So in order to increase the transactions per time unit, in order to increase the speed, the overall speed of the network, I'm going to use a more relaxed consensus algorithm because I trust Sula. So it has to do with trust. So and this gives me, as you will learn in the module that has been developed and for consensus algorithms, we have roughly two. Yes, I think so. Also mentioned Valentinos, our colleague who is behind this the machinery which delivers the content. So I can easily have Sula and Valentinos in this network with the simplest consensus algorithms. So yes, I was saying that as you can see, the consensus difficulty or complexity is a function of the public profile or inversely of the private profile of the network, and this gives me the chance to very quickly mention the two basic types of consensus algorithms. Of course, more details will be provided in the respective learning module. So the first one is called is what we call crash fault tolerant algorithm. This type of algorithms focuses on crash tolerance and is applicable mainly to private networks where the nodes, the participants are of known identities and there is strong trust among them. So the focus of this consensus is to make sure that even in the case of few crashes, the entire network is up and running. The second type of consensus algorithm, the second family of consensus algorithm is called Byzantine fault-tolerant consensus algorithms, and this type of algorithms is typically applied in public blockchains, public networks, where unknown nodes, meaning nodes of unknown identity, nodes that do not need to trust each other, participate, plus the fact that those networks have a native token like Bitcoin. In such types of such type of networks, the Byzantine fault-tolerant algorithms is being applied, and the main focus is to avoid phenomena like the double spending of funds, the double spending of cryptos. So the focus there is not so much on the tolerance in terms of crashes of the network, because we have thousands of such nodes. The focus is to preserve the value of the underlying cryptocurrency and avoid phenomena like double spending. So this is another way to explain how the type of the of the network determines more or less the type of the needed consensus algorithm. Let me also quickly mention what is crashing of networks. It's like imagine, yes, imagine that you have your computer, your node, connected into a network, okay, through an internet connection provided by a provider. So imagine that for any reason you lost your internet connection. So your node, your machine crashes, meaning that is no longer connected to the network. This is the notion of crash here. So this is, as Sula have mentioned earlier, many of those technologies are not so novel. In fact, many of them have been developed and tested for other areas. For example, consensus algorithms play an important role in civil aviation, where the cockpit, the central processing, let's say the central computer of the cockpit, needs to make sure that all the required measurements taken by the sensors would be available, even in the case of a sensor crash. So the airplane should be in a position to receive environment measurements, even if some of the sensors are out of order. This design principle, this engineering principle is called fail-safe, to have operational safety even if some of your computational elements fail. And the meaning of consensus is to make sure that the remaining available measurements are in agreement regarding the provided values. To give you an example, again within the context of civil aviation, the autopilot needs some GPS measurements in order to adjust the route. So I think the typical number of independent system that take those measurements and calculate the route is 12. So we have a redundancy at the order of 12 in order to make sure that we have independent measurements. And the agreement of those measurements has to do with the consensus. That is, the system agrees on those values, plus the fact that this system, this network of sensors continues to be operational even if some of them fail. That is, we have crash tolerance. This is, I think, a characteristic example of how ideas from other areas of software engineering and in general engineering has been adapted and used in the area of blockchains. So it's not something new. Any question? Okay, I think useful to proceed with the slides because I realized that we have spent almost, I don't know, 50 minutes for delivering a single slide, but I think, yes, this is the basic idea under those interactive sessions, to put emphasis on the question answering demonstration rather than only following the slides. And I hope to find this way of interaction interesting. So typically we have three main categories of blockchains: public, private, and consortium. The public blockchains are characterized by larger interoperability. They are censorship resistant, and they are good for global deployment, as explained. Private blockchains, like the small blockchain I have demonstrated, have a lower cost than public. My small private blockchain is comes with minimal cost as it runs on my machine. Of course, it is not so useful, but I can maintain this with very minimum costs as far as interoperability. Yes, interoperability makes sense especially for public blockchains, because those type of blockchains serve a wider audience. That's why. And we have a consortium, the consortium type that is closer to the private one. But let me once again emphasize that these three categories just give the rough directions. As it was explained previously and throughout our discussion, we have many types of blockchains in between of those three, let's say, labels. All has to do with the access to the blockchain, to the files that implement the blockchain itself, plus the consensus algorithm. So these are the three high-level categories. So interoperability, interoperability has to do with the ability of a system to work in conjunction with other systems. For example, let's go and see my private blockchain here. Okay, I was saying that I plan to invite Sula to access the blockchain, actually these two specific files here on my machine. However, if Sula's machine is not able to communicate with my computer, this particular computer, in order to access these two files, that we have zero interoperability between my machine and Sula's machine. If I say, for example, that in order to grant this type of access, a certain version of a certain operating system is required, and this only is supported only for that particular operating system version, the interoperability is minimum. If I say that those files can be accessed independently of the operating system, meaning that you can use Windows, Mac OS, major Linux distributions, or even your smartphones, then the interoperability is enhanced. So also, great. Single question about blockchain needs to be from the beginning. I think that makes sense to try to understand the needs of the application for which the blockchain is being developed as soon as possible, because changing the character of the blockchain may create some difficult situations. Some of them fall under the fork phenomenon. This will be explained in the context of the topic-specific modules, but the short and generic answer is it is a very good practice to have the character of your blockchain determined in advance. Yes, certain types of forks, if we talk about, let's say, strict hard forks, yes, those hard forks lead to new cryptocurrencies. Great. So just to give us some basic details about public and private and permissionless. In public blockchains, anyone can leave or join the network and validate transactions, while certain access types and variations of them hold for the case of public and private. The last bullet is was already discussed, and it is important that the consensus model are correlated with the type of the blockchain. Okay, this slide gives some interesting characteristics, some interesting characteristics about the Bitcoin blockchain. The main message here is that the Bitcoin blockchain constitutes the one end of the spectrum, being the ultimate example of a permissionless and open public blockchain, where anyone can join or leave, where anyone can, as I was saying, maintain a copy, even in a single hard drive of the blockchain. All the information is available. The network operators are unknown and trusted, and the proof of work is the consensus algorithm that is being used for building trust among those participants, those nodes. RIPL is an example that characterizes a blockchain paradigm that is shifted towards the private permission network. Not anyone can join the network. Permission is is needed, and the permission has to do with some specific roles. There are roles that determine who can validate new transaction, who can participate in the consensus. An interesting set of nodes is what is called unique node list, and interesting. This is actually a small set of nodes. It's a list of nodes, and only those nodes can cast votes regarding the validation of the transaction. Hyperledger, it's a configurable. Actually, Hyperledger is an umbrella for several blockchain-related projects hosted by the Linux Foundation. Hyperledger Fabric is the most mature and widely used project. Hyperledger Fabric typically is a consortium blockchain similar to the, let's say, Ripple one, similar to the small private network I have demonstrated. However, the interesting thing about a Hyperledger Fabric is that you have the ability to configure the network and move its character closer to the public or to the strict, let's say, private ends. So, in summary, the configuration of the consortium Hyperledger Fabric network defines the exact, let's say, characterization of public or private. And correctly, I assume that you have correctly imagine that such blockchains can be used where some certain cases in the enterprise world needs to be facilitated by those blockchains where limitations take place. And we are concluding this third part by this very interesting link to an introduction to permission blockchains. And thank you for your participation. And we continue.
Thank you, Ilya. Let me. All right. Thank you very much, Ilya. All right. Let me continue with section 3 now. No, I'm sorry. This is section, section 4. Okay. All right. Okay. Can you see my screen? All right. we're going to continue now. Ilya, can you hear me? Everybody hear me?
Yes, but
Can you see the screen? Let me. All right, Valentino, I cannot see the sharing part. Let me. All right, share my screen. Can you see my screen now? All right, let me go find the chat also. Great. All right, thank you, everybody. And we're going to continue now a little bit more on cryptocurrencies, discuss a little bit on smart contracts, centralized and decentralized applications, and then again some references at the end. All right. Now, cryptocurrencies, of course, they are free of permission. Anybody can download the necessary software and mine or trade, and be able also to purchase things with cryptocurrencies. Now, as we have already mentioned, no permission is required by some sort of a bank, a central bank, or any other monetary authority. So they do have cryptocurrencies such as Bitcoin, such as Litecoin, Ethereum, and so on. They do have several different features and properties which differentiate them from fiat currency that and cash that we use in our everyday life. In fact, using cryptocurrency like Bitcoins, they prove to be very safe, secure, and so what we're going to do is to look at some of these characteristics that they have. As we said, they are free of permission. They are irreversible. Once we do send money to someone, then that transaction cannot be reversed. They are highly secured due to the cryptography that we have mentioned before. Instantaneous transfers may take place at once, unlike the various banking transactions that sometimes, especially sending money from one country to another, it may take a few days or even a week for the transaction to be completed. The physical location, in this case, it does not matter. We only need the internet access, our computers, and the necessary software to be able to transact. As we have already mentioned, they are pseudo-anonymous. The cryptocurrency transactions and accounts are not linked to any real-world identities, currencies such as Bitcoins. Of course, there are ways for someone to try to trace them. Tracing techniques have been developed because initially many were, some actually, were trying to use cryptocurrencies for illegal purposes, such as buying drugs and so on. So, of course, techniques were developed and are being developed by various authorities to be able to trace those types of transactions and currencies. All right, so moving next to the types of cryptocurrencies, the Bitcoin that we have mentioned quite a bit this evening. it's actually the most well-known. It allows the users to make transparent peer-to-peer transactions. Litecoin, some of the differences between Bitcoin and Litecoin is Litecoin is believed to feature faster transaction times. The coin limit for Bitcoin is 21 million, whereas for Litecoin is 84 million. Ethereum focuses also on running the programming code for any decentralized application and allowing it also to be used by application developers to pay transaction fees and services on the Ethereum network. And of course, nowadays, there are lots of different cryptocurrencies that one can be using. Mining, a little bit on mining now. It is actually the way that new Bitcoins or any other cryptos are being created. Miners publish actually blocks, as we have already mentioned, on the blockchain. And as a reward, the miners receive Bitcoins or any other crypto they're working with. For the first 4 years that the Bitcoin blockchain was out, 50 Bitcoins was the reward for the miners that would have the block being that would have the block. Miners also, they get transaction fees. The race to find a conforming hash is about every 10 minutes. And they do that by trying to solve the consensus algorithms, if we're talking about Bitcoin, proof of work. The first ones to solve the problem and to publish the block on the blockchain, that includes all the it includes basically the transactions that have taken place in the last 10 minutes. The reward is halved every 210,000 blocks, which is approximately every 4 years. We have already mentioned that there is a fixed supply for Bitcoins, 21 million. In September, for example, 2019, the reward was 12.5 Bitcoins. And that was followed back in May by halving it to 6.25 Bitcoins for the reward for every block. And the next halving is actually expected to take place in 2024. In regards to the transaction fees, the users include transaction fees in their transactions as payment to miners for processing those transactions. Transaction fees follow the market forces, of course, and supply and demand. Okay, all right. When blocks are full, the fees are very high. Bitcoin prices over the years, they have ranged. For example, in July 2010, it was around 8 cents. We saw a very high increase in December 17, going to about almost 20,000 euro. And actually, this few weeks, the past week, it was more than $35,000. So we see that its price has really been fluctuating. Now, one may ask, how might the Bitcoin halving impact the Bitcoin prices? How the Bitcoin, the prices, they actually fluctuate, it's not clear yet. It could be because of the increased news and coverage that we see through social media and other mass media. It could be because of the various investors. So how the price fluctuates, it's not clear yet. One may ask, what will happen when all 21 million of Bitcoins have been mined? Well, users will not receive new Bitcoins for verifying the blocks, but they will continue to receive transaction fees contributed by those making the payments. Now, some more useful definitions and explanations. Dual key encryption, or public key cryptography, as we may sometimes refer to it. We are using this so that these definitions now, so that we are going to see how we are actually using them later when it comes to cryptocurrencies. All right, the dual key encryption basically uses two keys, one that is being used to encrypt our transaction, and the other one to decrypt it. The key that, of course, encrypts cannot decrypt. The two keys that we use is the public key and the private key. The private key, it's kept only to us, nobody else knows about it, but the public key, of course, as the name says, is actually public. Public key cryptography is most often used also when encrypting messages between two people or two computers in a secure way. Anyone can use someone's public key to encrypt a message, but once it is encrypted, only the person with the private corresponding key can decrypt it. Digital signatures, again, another concept that is being used when it comes to cryptocurrencies. Digital signatures, similar to handwritten signatures, it's actually an electronic verification of the sender, and it's being used for to authenticate the receiver. So it's being used for authentication. It gives the receiver the reason to believe who the specific sender is. For integrity, that the message was not actually modified along the way. And for non-repudiation, the sender cannot deny later that he or she has actually sent the specific message. And we use digital signatures to create valid transactions. Transactions, as we said, they can vary. We could be talking about financial transactions, software distributions, and other cases where forgery and tampering may occur. Address. We have already, okay. we have already looked into the Bitcoin address. The transactions in the blockchain do not actually record the public keys or the recipients, but instead they use what we call the Bitcoin address to record the beneficiary of each amount, allowing for greater flexibility. So if I have my Bitcoin, someone that wants to send me some Bitcoins, for example, they will be using my address to send me the Bitcoins. So to create a Bitcoin address, the client software for Bitcoin will generate a public-private key pair by from some random number, and they are created and stored offline. Now, as we've mentioned, the private keys are kept secret and they are only being used by the current owner of Bitcoins to digitally, that uses them to digitally sign a transaction. And a digital signature confirms the new ownership and can be used to verify that the specific transaction is actually authentic. The public key is generated from the public key. So in answering the question that I see here, public keys can be created out of the public, private keys can be created out of a public key. Yes, where we are generating the private keys using a one-way cryptographic hash function used, and it is used by the new owner to validate the digital transaction. The Bitcoin addresses, they are represented as a string of characters, or many times as just as a QR code. Creating two addresses, actually, we're using the way that the addresses are being created. I don't think this is possible to, looking at the question that I see here, I'm sorry. What if two people create two addresses and the random numbers are the same? This, I have not seen this actually happening, and I don't think this is, I mean, random generation, it works in such a peculiar way that this is very strange. I don't think this can actually happen. We have not seen it before. And the way that these generators work, I don't think this is possible. So, continuing with the notes here, anyone or an app, an application can send Bitcoins to a specific address. The holder of the private key associated with the address can use it. The scheme usually begins with, the scheme to generate the Bitcoin address begins with the private key from which the public key is derived. And from this public key, the Bitcoin address is derived. We're talking about a one-way process, and one cannot derive a public key from a Bitcoin address, and one cannot derive, of course, also the private key from the public key. in this slide here, I call it playground because I also use visual representation. It's an online tool of how to actually create a Bitcoin address. So feel free to go back to the slides and try to play with it. So as we're also running out of time, please go over this slide and try to create your go over this visual representation and see how this is actually being created. Now, the process, when transactions are broadcasted over the network, remember the SH256 is the hash algorithm that is being used in blockchains. It is being used to verify the data integrity. That is, they are establishing, it is being used to establish that the data was not corrupted or modified during the transmission. All of the Bitcoin transactions, they're being stored in the blocks, which are linked or chained together in sequence to form the blockchain cryptographic hash functions that are generally used. So they verify block integrity, and at the same time, they establish the chronological order of the blockchain. Remember that everything is being time-stamped. And Ilya, I think this is the point at which I pass the floor to you again.
No, thank you, Sula.
Thank you.
Can I see that you can see me, hear me well? Now
You need to share your screen.
Share.
Why am I not muted?
Okay, I think you can see my screen. So, can you see me, hear me well, see well my share screen? I think yes, given the time, the context of the time, I will try to deliver the remaining part of this slide set by focusing on the most important slides in order to have few minutes for the last parts. So let us see a typical example. Let's assume that George wants to send some cryptos to Helen. So George sends the cryptos to Helen using his private key, which is associated with his wallet. The Helen is identified through her public key address. Once this is done, the miners of the network see that the transaction took place. They collect all independent transactions and trying to solve the mathematical puzzle that is part of the proof of work. And the miner, this is singular, the miner who solves the problem publishes the block and gets a reward of bitcoins. And at the same time, it is recorded that George and Helen received the confirmation that their transaction has been successfully executed. This process is happening without showing to the end user the internal details. Everything seems to take place without having all these steps behind it. So in order to do so, we have some specific applications called wallets. The wallets are software that is used to store cryptocurrencies and enable such transactions. So their primary purposes are to generate and manage Bitcoin addresses and the related cryptocurrencies. Can be regarded as similar to email addresses, and they can generate unlimited virtual limited addresses and move funds from one wallet to another. Now, there are, I think the mechanics of private and public keys was excellently summarized by Sula just before. So let me focus. We all understand the basics of the private and public keys. Let's focus on the type of wallets. That is the software that manage those addresses in conjunction. Let me put it this way: in conjunction with the movement of crypto funds. So we have few types of wallets. We have mobile wallets, online wallets. The common characteristic of those wallets is that they are provided by third parties. The former case run on your mobile. The latter case is web-based. So they have certain characteristics. They are convenient. However, their key characteristic that is not so very well aligned with the decentralization aspect is the fact that they are provided by a third party. They run on usually on a central server, which introduces some degree of centralization. Likewise, we have desktop wallets. The interesting type of wallets are the hardware wallets, which gives you more control and decentralization in your hands. Typically, USB wallets, this type of hardware, it's the typical device for implementing your hardware wallet. Also, we have the paper wallets, where, as the name suggests, a piece of paper is the medium where the credentials, public and private addresses can be stored. And a nice way to keep safe such stored information is keep it away from an online connection. And this is the idea of cold storage, which refers to an offline medium for storing Bitcoins, actually for storing the credentials of your addresses, mainly your private key. So this is pretty much the idea here. And under the web-based wallets, we have some broader services which provide web-based online wallets, and these services are known as cryptocurrency exchanges. These services, in addition to the implementation of web-based wallets, give the opportunity to the subscribers to exchange cryptos. For example, exchange Bitcoins for ETH and very numerous other combinations of cryptos. And as mentioned before, the drawback of those exchanges is the fact that they are not they are not fully decentralized since they are being controlled by some third-party entities, and they usually run on servers, again, owned by some central authorities. So this is a nice comparison between centralized and decentralized exchanges. There are certain differences. The main take-home message is that decentralized exchanges offer some decentralized characteristics, but they are not fully decentralized. And we have some hybrid examples. The last thing is about smart contracts. Let me say that in this introductory module, we are giving only the general direction. Please be informed that a smart contract specific module has been developed in the context of the DLT4ALL project. The main message in this part of this topic is that smart contracts are software, are programs that are developed using certain programming languages. And the interesting characteristic is that they can be executed on the blockchain. This gives some interesting properties, like the one listed in this site. They can be used for automating contractual agreements, and specifically the combination of the ability to program something with the existence of a native currency makes the development of blockchain-based applications, or known as decentralized applications, possible. I think that the most interesting example of smart contracts is the Ethereum blockchain, which comes with the Solidity programming language. The Bitcoin blockchain has a minimal support of blockchain programming in terms of smart contracts. And this is because Bitcoin is mainly for transactions, Bitcoin transactions, while the Ethereum supports a wider range of decentralized application, but this will be explained within the context of the smart contracts specific modules. And here we summarize some interesting applications that are enabled through smart contracts, like the settlement of agreements, and actually the list is buying properties, etc. The list of possible applications is very, very huge. Let me also say that in addition to the smart contract specific module, we have an additional module focused on the development of decentralized applications. So this is just the high-level presentation of what to expect in the other learning modules developed within DLT4ALL, and this is an excellent list for further reading. And I think I can pass the floor back to the virtual floor, back to Sula. Yes?
Hello?
Okay, can you hear me, Sula?
Yes, I can hear you.
Mm-hmm.
Okay. All right. Let me then move to the next section, which is actually the last one. All right. Share my screen. And I need to open the other file. Okay, give me a second, please. All right, can you see my screen? I cannot see. All right.
Yes.
Great. Let's put it shut over here so that I can see it. All right, use cases. I will just briefly discuss a couple of use cases, but tomorrow evening, same time, we are having an invited speaker, Gleb Gonodov, who is going to tell us more about the use cases that and the applications that they have been working within his own firm. So let's start on that. All right, as we have already mentioned, blockchain technology as such, it can be applied in several industries, ranging from financial services to accounting and auditing to property ownership to certificates that we are also using here at the university to energy management and many more. Now, in the food industry, one of the specific use cases that has been used, it was in the supply chain. IBM, Dole, and Driscoll, Kroger, and McCormick, some other companies, they use the technology to trace contaminated food. It's it's a fact that more than 400,000 people die every year from contaminated food. So through the use of the technology, they were able to trace it. Usually, it takes weeks to be able to identify the precise point of contamination. Remember, due to the fact that transactions on blockchain, they're timestamped, if these types of transactions are on the blockchain, we can actually trace them back and identify at which point in time and where the contaminated food was through the supply chain. In shipping, IBM and Maersk started testing blockchain technologies a few years ago. They initially started on a pilot case where avocados were shipped from Mombasa to Rotterdam. It was estimated that it is estimated that shipping carriers can save up to 38 billion every year through these types of applications. And Maersk aims to get 10 million out of its 70 million containers to be on the blockchain. This brings us actually to the end of this session. Some final takeouts. what about blockchain? Remember that a blockchain is a shared ledger enabling participants in the network to see the ledger of transactions. A shared ledger with technology that enables decentralized secure transactions. The transactions are placed in blocks which are linked by one-way hashes. They are append-only, we cannot modify them, and cryptographically secure. They operate in peer-to-peer mode, and each peer address is anonymous. So overall, we can look at Bitcoin as a collection of concepts and technologies that form the basis of a digital money ecosystem, including a decentralized peer-to-peer network, a public transaction ledger or private, depending on what we're using it for. But here we're talking about the Bitcoin blockchain as such, a decentralized mathematical and deterministic currency issuance mechanism. It is, blockchain as such, is a decentralized data structure that allows untrusted parties to trust each other. We use cryptographic hash functions and public key cryptography. Three main categories of blockchain: public, private, and consortium ones. We talked about cryptocurrency wallets, smart contracts, and decentralized applications. This brings us to the end of this module for tonight. Remember, tomorrow we are having the more specific use cases to be discussed, to discuss with. Can you see my screen now? Because I changed, okay. What I have put up to here, all right, these are the rest of the modules that will be taught for this, for the whole MOOC that we launched today, we kicked off today. On January 18 through the 22nd, we will be discussing P2P, peer-to-peer database design. Instructors for the rest of the modules will be colleagues from the partners, Luca Ferrario and Alberto Gufanti from GomoNext, then January 25th to 30th, encryption techniques with Pablo Lopez from Spain, consensus mechanisms against Spain, digital signatures, we go back to Italy, smart contracts, we go to Greece, privacy and property rights, again, back to Greece, blockchain-based decentralized applications for the following week, March 1 to 5th, it's again here to Cyprus with Dr. Klitos Christodoulou, Dr. Marinos Themistokleous, and Dr. Elias Yosif. And March 8 to 18th, the decentralized autonomous organizations with Edward Valley in, we go to Belgium then. Following that, remember, we are going to have an exam a few weeks after the end of the last module. And the short assignments and quizzes that we are having for each individual module. I have a question here if there will be daily classes. There will be a variety of things every evening. The schedule, you can download actually the brochure from the platform where you can see the whole schedule and when all the different classes are taking place. Tomorrow, I plan, for example, to spend a couple of hours on these use cases by Dr. Glib. And the following day, we're going to have about 1 to 2 hours, let's say office hours. I will be online along with Elias to discuss any other questions that you may have. Virtual office, yes, free discussion, questions and answers. We will be online in case that I assume that by then you will have gone over your the material, and we can be discussing other questions that you may have. In addition to that, we plan to the rest of the partners will be doing similar live sessions with the rest of the material. So I would like to thank everybody for participating this evening. Thank you, Elia. Thank you, Valentino, for all your support. And
thank you, Shula.
See you all tomorrow with the use cases. Thank you. Have a nice evening.